Welcome to another episode of Science and Technology with Felix Pham from Vietnam. In this episode we will have a look at writing our first alert bot. Because this already took longer than I anticipated, we will not have time to actually put it together with our Slack notifier. So today we only write the bot, and in the next episode I will put it into a system that really alerts us in our Slack application. And because it already takes longer than I thought, we will jump right into the implementation. Let's have a look at what I changed since we last had a look at the listener. For one, I added type hints. These don't affect the execution of our program, but they do offer some readability improvements. People who look at the code know exactly what kind of value I need to provide. And also they can be used for static code analysis to see if your calling tree has any type errors, if you use wrong types when you call methods. But I use them mainly because I think they help with readability. The next thing I added was the on-error callback handler. I'm not really handling the errors, but I want to at least log them to output. So if we see errors, we can then decide how we want to deal with them. For now, I'm not exactly sure what type of errors to expect. And another very big change in the code is that I actually made the subscribe aggregate trade method blocking. So before that, we said, okay, we get ourselves a message ID, and with that message ID, we subscribe, and we just assume that it works. But I decided to hide that abstraction from the outside. To do that, I actually added a helper module that I designed, which basically takes care of incrementing the message ID and also should be thread safe. And also it handles the message ID internally, so that when I actually send the message out with that message ID, I can then after that just wait on that message ID to get a return, get a response from Binance. And how do I do that? Well, I also needed to update our on message callback. And here I now look at the content of the message, and I decide if I see the ID field, I assume that it's an answer to a request we sent. When I see an ID field, I consider it a response, and I tell the ID manager, here I have a response for the following ID, please take care of it. And if there's no ID field, then we have our usual behavior. But you can also see a little change here, because I now take care of those maintenance management functionalities. I now really only return the message at that point. I don't need to consider here, oh, we have an open message that comes back or anything, because we can now, with this blocking method, I don't care if the WebSocket is already open or not. Because this is a blocking method anyway, I can also say not only do I take care of waiting for a response for my request, I can only take care of waiting until our WebSocket is actually open. You can have a look at the ID manager, but for now, just note that it takes care of incrementing our ID and managing the association between response and request. Another utility I created is the preprocess.py. In this module, I take the event we get from our WebSocket endpoint and I convert it into an internal representation. For now, this is a one-to-one mapping from keys within the event onto some more readable keys that we use internally. This layer can later be used if we have different endpoints from different vendors, then we can have a common internal representation. So for now, I just take some of the keys we get in our event and give them some more readable names. I also only take one of the timestamps, and I believe this is the timestamps the matching engine at Binance actually did the trade. And because it is provided in milliseconds, and in Python we usually work with seconds when it comes to time, I convert that into a seconds representation. Another thing we can see here is that I have a top level function, and this top level function is specific for Binance, but when it gets any event At the moment, we only have one supported type, but if it gets an event, it automatically distinguishes between them and calls the corresponding preprocess method. Let's design our first simple version of an alert bot. I do that in Vim Binance bots. I want to start with defining a superclass first. So I call this class bot. So first I want to define a method that I call to actually provide the bot with new events, with new aggregate trade data or what other data we have in our system in the future. And I call this digest event. And of course, I need to get an event here. For now, we don't have a class to specify how events look like. So for now, I will go with a simple dictionary as a type. But in the future, we might have a class to be a little bit more descriptive about how an event has to look. This method really just congests the event and there's no return value expected. And the second method will be the update method. My idea here is that on the one hand, we get events at all times and we don't know with which frequency and so on. So the first method will just be called whenever an event is coming. But the update method I want to call in a certain time interval. So maybe about every second I want to see if there are new events that need to be processed. And of course, this returns an event, a new type of event. And for now, this will again only be a dictionary until we know more. And of course, we need to import the type hint. I decided to start with a simple bot. First of all, because I'm not a financial expert, so I don't know what kind of signals are especially valuable. You can write down in the comments below if you have any ideas about signals you want to see, but I will go with a simple signal. I will write an alert bot for volume. So if there's a certain threshold of traded volume within a certain interval, then I want to alert. So for example, let's say ADA USDT has traded more than 1 million ADA in the last 10 minutes. Maybe that's an event that it's noteworthy. Maybe something is happening and I need to alert people to have a closer look at it. So this will be our first bot. Okay, we definitely will have our methods from the superclass. And then, of course, we might have some specific initialization for the bot as well. Let's consider what we might have that we need. So what parameters do we want for the bot? Well, definitely we want to set the volume, which we say will be a float. And we also need the ticker. So we want this volume bot to only work for a specific instrument. So we need to set the ticker, which will be a string. And we want to set an interval. And in Python, a lot of time intervals are set in seconds. So I also set it in seconds. This would be enough to basically build our bot. But one thing we need to consider is if we get an alert, when should the bot reset? So we probably don't want to have, once the volume threshold is broken, probably it will be broken for the next 30 minutes or something, and we don't want to have an alert every second. So we need to have some kind of cooldown for our alerts, which again will be a float. And maybe we can even set a default. Maybe we say we want to be alerted only once per hour. And we can also set defaults for the other things. Maybe our default interval is, let's say, 10 minutes. If in 10 minutes something special happens, then we want to be alerted. For volume and ticker, that makes less sense because ticker depends on what the person wants to look out for, and the volume definitely depends on the ticker. So no sense in setting reasonable. There are no reasonable defaults here. Another thing that we might want to add is an exception to the cooldown. So maybe we have a relatively reasonable volume threshold, and when that is broken, we get an alert, and maybe we are like, yeah, okay, I got that already last hour, maybe I'm not interested. But maybe this time it starts increasing even further. So maybe there's a point where we do want to have another alert. So I call this a cooldown exception. So when the threshold breaks another threshold, then we want to ignore the current cooldown. So I make that in a percentage value. When the new interval breaks the old alert by a certain percentage, then I want to be alerted again. Let's have reasonable default 20 here. If the threshold is broken by more than 20%, then we want to have another alert. And then we need to, of course, save that all here. Okay. Let's go into our digest event. What do we have to do here first? For one thing, this bot will have to take care of filtering the corresponding events himself. So in the design I have so far, I will let that be done by the bot. So first we need to see if the event is actually of interest to us. So if event type is equal to aggregate trade and event symbol equals our self.ticker, then we want to digest the event. Let's turn that around. Let's say if that is not happening, then we just want to go back. And I also want to have that because the line is getting too long and I don't like to have multi-line if statements. So I put that into a variable and then have a one-line if. So skip equals so skip equals what we just said. And of course, I still need to invert the statement. So if either our type is not aggregate trade or our symbol is not equal to our ticker, then we want to skip. And if skip, then we just say return none. Oh, actually, we don't need the none here. And otherwise, we do our logic. And how do I want to do the logic? The volume calculation over a certain interval acts like a box filter over the incoming market data. We can see here that while the time progresses, new events come in from one end and other events fall out on the other side. The problem we have here is that we don't know how many events will come in, and depending on the market situation, our bot will have a highly variable load when it comes to storage resources. Even though we could implement it in a way that we save every incoming volume information and then we kick out those volumes that are out of date, we want to do it a little bit more optimized and a little bit more deterministic when it comes to resource utilization. We cannot simply have a single volume variable that we add all the new volumes to, because then we don't know what kind of volumes we need to subtract when some of them are out of date. But we could go some in between. So we could create multiple buckets and merge multiple events, multiple volume events into a single volume event. As we can see at the side where the events are falling out, this is not as accurate as saving every single volume event, but depending on how fine-grained we make those buckets, we can increase the accuracy of our window. But it does definitely help us in having a very deterministic way of saving our volume information. To do that, I need to have a storage for our buckets, need to have a data structure for our buckets, and I decided to simply use a dictionary here. So our buckets is equal to dict. And the keys will be the bucket ID, and the value will be the summation of all the volumes that were observed in that bucket. So what we need to do here now, if we get an event, if we get a trade event, first we need to get the volume, and then we need to decide in which bucket we need to add it. So first let's get out the volume and the timestamp of the event. So our volume is actually our event.quantity, and our timestamp is event.time. And then with the timestamp, we now need to calculate which bucket we belong to. And I decided to do that in an extra method. This way we can reuse it for the update method later. And it's easier to maintain if we only have one code base instead of duplication. I call it bucket index, and I expect to get a timestamp in here. And let's say, no, needs to be an instance method, needs to be a method of the class. And I return an int. I return the index, and I get a, let's say we return a float. So how do we calculate the timestamp? Well, first we need to consider how big should our buckets be. So I call this parameter the bucket width. And right now we want to have it 30 seconds. Again, we try to use seconds with Python, so we don't have to deal with unit issues. And now we have to divide our timestamp by our bucket width. And with that, the bucket index is nothing more than the timestamp divided by the bucket width. And we make an int conversion here because we want multiple timestamps to fall into the same bucket. And if we return a float here, then that would not help our cause. Then we would not have multiple timestamps mapping to the same bucket index. Okay, that's all for the bucket index function. So our index is self.bucket index of our timestamp. And then I need to update the bucket within our buckets data structure. The thing is, we don't know if this bucket has already been created or not, because it could be the first volume information for the bucket. And I like to do it by just returning the current value self buckets.get. I use the get method of the dictionary. And here I can return a nice default argument if there is no index, if there's no value for that index in the bucket in the dictionary. And then I actually set the bucket at the position index with the current volume plus our new volume. Okay. Now that we have written that all down, we can of course try to reduce that. We can say, okay, I can simply reduce some lines here without it becoming less readable. And I also, oops, this is a function call, of course. Yeah, same here. I also don't need the event time another time. So I can also just put this in here. Hello, it's me, but from the future. I'm here to point out some of the mistakes my much younger self made. Here it needs to be self.buckets. Next, we go to our update method. Because our volume bot needs to know what time it is right now. Let's get that. And also we need to import time, of course. And the first thing we want to do here is to actually clean out our bucket list. So in the digest event, we are just growing that list and growing that list and growing that list. But at some point, we need to kick out those buckets that are no longer of interest. And we do that here in the update. We could do that differently. We could have some kind of timer that automatically says, okay, our bucket is now stale. We need to remove it. But for now, we just go the brute force way. We just, every time we come into the update method, we check if we need to throw something out. And I will use our bucket index method to actually pre-calculate the oldest timestamp or the newest timestamp that we need to kick out of our list. It could be that there are multiple buckets we need to kick out if update wasn't called in a long time. So our timestamp threshold equals self dot bucket index from now minus self dot interval. That should provide us with the timestamp. And then I need to go through all our events. I will just say self dot buckets equals, and then I use a dictionary comprehension to reduce all the buckets that are out of date. So here I want to have key value for key value in self.buckets, and only if key is bigger. And now it's the question, do we want to have it inclusive or exclusive? Depending on how small our bucket width is or how high our resolution in that case, that might not really matter. So you can consider making it bigger or equal or just bigger. I just go for bigger. It's of course a threshold, not a threshold, whatever that is. Threshold. Another me from the future. Here I need to use a comma instead of a colon. Buckets without underscore. And of course it needs to be buckets.items. And the next step now is the actual calculation of our volume in that time. So we can now do that with a simple sum over all the partial sums that we already have in our bucket list. So self.buckets.values. Yeah, and now we could start doing some gating. We could say like, yeah, only if the volume is above our threshold, then we want to do something. But for debugging purposes, it might be easier to construct everything in a linear fashion and then just send it out if the volume is the threshold is crossed. But we still constructed the event internally. Again, that is something that if you are out for high efficiency, you should probably rewrite. So let's create an event here, which will just be a dictionary. And we need to consider what we want to have in here. And I believe it would be wise to have some kind of type in here where we specify which bot produced that event in case we want to continue to process it. Maybe we want to have bots that react on bot events. So let's say this is a volume bot. Might not be enough. Maybe we need to have more information here. Maybe we will have an ID for the bot later that we want to add here, because there can be multiple volume bots for different tickers and so on and so forth. So this is definitely something that we need to expand if we want to have it more complex. But having the type here will help others to know if there are some type-specific fields in the dictionary. For now, I will just put the volume into a value field, which could be quite the generic field that could be in every event. So that might not be volume specific. And then to make things easier for now, I will have a text representation of the event in here that we can just write down as it is without having to care about constructing an output based on the type. So I will have, in every event that I produce, I will have a simple text that can be used for debugging purposes or for simple exposure of the event. And I want to have a timestamp in here that definitely helps with debugging. And I use f strings again. And let me put in here datetime.datetime from timestamp now. And yeah, we can decide how we want that to look. So I just use the arrow here. Then maybe the ticker next, followed by our actual volume. Because we have floats here, and of course I don't know if we have partial volume. Depending on the ticker, the different decimal points might be of more significance than for other tickers. So for Bitcoin, because it's so expensive, probably a lot of times there will only be partial Bitcoins, maybe millibitcoins being transferred. So that might actually be important. While for other tokens that are cheaper to buy, to purchase, it might be totally irrelevant to look at the decimal points. So for now, I will just add, let's say, 1 decimal point here to the volume. And then just say traded in the last self.interval seconds. Here, of course, if you set the interval to 1 hour, then of course writing it down as 3,600 seconds is not necessarily readable, but this is just the simple version here. So for now, I just go with seconds. And I also want to add the timestamp, which is our now. Okay, and maybe now, as I said, I want to create it in a linear fashion so that I can use it for debug purposes. So maybe I use this point here to lock the message in case we have debug on. Created volume event. And of course, I didn't actually initialize our lock in this class, in this module yet. So import logging, and my log equals logging get logger from name. Okay. And now we need to see if we actually need to consider this event or not. So there are actually multiple things here, and we can again do that in an if-else tree, but that makes it less readable. So even if it makes it less efficient, I will write everything down in a linear fashion. The first thing I want to know, is this actually above the threshold? And I call that trigger. And this happens if our volume is greater than our previous volume, which we have not yet defined. We still have to do that. Of course, the trigger must be equal to the greater or equal to the defined volume. Then we want to know if our cooldown has cooled. So we call it cool. And this happens if now is greater than our cooldown plus our previous timestamp. Okay, let's define those. So we have our previous volume. so that in order for it to always trigger, we should set this to 0, and our previous timestamp we set to also to 0. Unless you live in the past, that should make this immediately be cool for our first event. The next thing, we also wanted to trigger if our volume exceeds a certain extra threshold. So if our volume is 20% bigger than the last time we triggered, then we don't care for the cooldown either. And I call this significant, because then it is a significant volume change that ignores the cooldown. And this is volume is bigger than self dot previous volume times 1 plus self dot cooldown exception. And this is now too long for one line, so I'd like to have my lines no longer than 70 characters. We defined our cooldown exception in percentage. And now we can have our if structure, which now looks easier to handle. So we want to send out our event if we have our trigger and we are either cool or we are significant. And in that case, we want to, first of all, we need to update our previous timestamp to now and our previous volume to volume. And then we can return our new event. And because we get a warning if we have an implicit return and an explicit return in the same function, I now need to also have a return here. And that is our simple volume bot. We return an event if our volume exceeds a certain threshold. Thank you for watching. I hope you enjoyed it, and if you did, please leave a like and subscribe. And if you want to support me further, please consider staking your ADA with my Cardano stake pool Felix Pham, ticker name Lix. A quick shout out to the operator of the Lina Tron stake pool for creating this amazing web app. It shows the different stake pool locations based on the first relay that is registered with the stake pool. And it offers a very nice way to see where the Cardano nodes are located within the world. And it also has a nice feature. You can enter the name of whatever pool you like. So of course I'm looking for my pool, and it will automatically have a sequence where it locates that pool on the map. And it shows my pool within all the other pools that are located within the data center in Japan. Also has this rotate feature. So it's just a very nice web application that visualizes the Cardano network in a very interesting way. So if you want to support him, he's operating a very small pool. Any stake you can spare is very welcomed. So visit his website and stake to his pool.